All right. So I hope you are going to make the plot. You are going to make the smooth curve and using the values that we have just noted down over here, right? So there is no rocket science in plotting this graph. Now, deduce the experiment in which the rate of reaction is fast, right? The fastest. So look at here. At this temperature, the time taken to complete reaction was, in first experiment, the time taken to complete the reaction, the time taken for texting to become visible, meaning is that the time taken to complete the reaction is 116 seconds. Whereas in second experiment, 80 seconds were required to complete a reaction, in third 69 for. So the fifth reaction will be the fastest. Why? Because it is taking less time to complete the reaction and to visualize the mixture, right? To clearly see the bottom text through the clear solution. Now again, use your graph to predict the temperature of the solution when the text becomes visible after 55 seconds. Again, for example, let's assume you're going to, this is 1 2 3 4 5, this is for example 15 sec, 16 17 18 19, this is for example 20, and also 1 2 3 4 5, this is 25, and so on. You are going to do like that, and then at 55 seconds, let's assume over here or something over here, you'll have to check the temperature and you'll have to write it. So there are 2 marks for this question, right? One mark is for working the graph, or basically 55 सेकंड पे कौन सा टेम्परेचर है, कौन सा वर्किंग आप लोग कर रहे हैं, basically the working that you are going to show on the graph at 55 seconds. And also the next point will be for the temperature, writing temperature over here. For example, let's assume कोई भी temperature है, for example XYZ temperature, X degree Celsius. 1 mark is for this one over here, and 1 mark will be for the working that you are going to show on the graph, right? So next question is, explain why wrapping the beaker in cotton wool after it has been heated will improve the accuracy of the results obtained. Why? Because remember, cotton wool can act as insulator, right? So what do you mean by insulator? To protect the heat or to reduce the heat loss from the beaker, right? So the reaction, during such reaction, as we are doing these reactions in a simple beaker, so some heat can be released to the surrounding from the system. In order to do this experiment with more and more and more accurate reading, more accuracy, you can cover the beaker with cotton wool, which is acting as an insulator, so that minimum heat is being released to the atmosphere and you get proper results, you get clear results. So there are again 2 marks for this answer. The first mark will be for reducing heat loss or some sort of insulation. You can tell that cotton wool will act as an insulator, right? This is 1 mark. And also remember, temperature changes will not be wider. In other words, temperature will remain like more and more steady, more and more constant. In other words, variation will be less variation, less temperature change, almost constant temperature readings, temperature measurement, right? No wider change in temperature. So these are the 2 points that you are going to discuss while answering this type of question. Again, explain why it would be an improvement to measure the volume of aqueous iron nitrate in burette rather than measuring cylinder. Of course, in ATP, you have studied that multiple times, because yes, burette has more accuracy as compared to measuring cylinder. This is the simple topic that everybody knows. Beaker, the measuring cylinder is more accurate as compared to beaker, and burette is more accurate as compared to measuring cylinder and beaker as well, right? So you can say that burette can measure more accurately as compared to measuring cylinder, or simple more accurate. This is simple, right? So again, Suggest why it is not to be an improvement to add aqueous thiosulfate using a pipette. Why? Because, yes, please. Wait, sir cannot enter. Let me send him the link again. Can anybody send link to Abdullah Hassan? 20 students. Please, anyone send the class link to Abdullah Hassan.
I have already sent him the link.
Let me send him a short invite. Just wait for me, please. Copy invite link. It's copied, and then I'm going to send it. All right. So, why we are not going to use the pipette? It is not advisable. First of all, pipette has generally fixed volume. Pipette can measure fixed volume. Next point is that these are the ionic compounds like aqueous iron nitrate, which means that iron will be in the form of +3 and nitrate will be in the form of -1. Point number one. Similar is the case with sodium thiosulfate. Sodium will be in the form of Na+1 and thiosulfate will be S2O2O7. Let me check. I'm not done yet. I'm not done yet. Wait. Sodium thiosulfate. I've forgotten. Sorry about that. S2O3. This is it. Sodium S2O3 minus 2. Again, they're doing this question. What? S to sulfur होता है ना? So what? Now remember, look at here, please. We have in rate of reaction chapter that rate of reaction of covalent compounds is low, whereas the rate of reaction of ionic compound is fast, right? This is an ionic compound as well as this is also an ionic compound. So as soon as we are going to mix these two compounds, they will start reacting immediately, right? Their rate of reaction will be faster as compared to the covalent compounds or the covalent molecules. See, in the graph in the above table, we just studied that the rate of they are basically reacting within seconds. 116 seconds is not like that ample amount of time as compared to covalent type of reaction. Covalent compounds take much more time, even hours, right? Whereas any compound is the reaction between any compounds is just taking minutes, seconds, right? So remember, when you are going to use pipette for adding sodium thiosulfate, then pipette is very slow. Through pipette, the liquid will be adding slowly, drop wise. Whereas we don't want to do that. We want to suddenly pour the sodium thiosulfate to aqueous iron so that we can evenly check, we can react these two compounds evenly at the same time, and we note their temperature, right? If you are going to use pipette, this is for example the shape of pipette, right? And you are going to use drop wise, then what will happen? The reaction will be proceeding very slowly, and also we will be unable to measure we will be unable to measure the accurate readings. So in order to measure accurate reading, you will have to mix both these compounds, or you will have to add sodium thiosulfate suddenly to basically it is very slow to add through pipette, or a reaction will start slowly by adding the sodium thiosulfate. Now suggest why the aqueous sodium thiosulfate must be added after the aqueous iron nitrate has been heated, not before it is heated. What we have done in the experiment, we have first heated the aqueous iron nitrate and then we have heated it before adding the sodium thiosulfate. And when we are done with adding sodium thiosulfate, then we have heated it, right? So why have we done that? Anyone? Yes. Any other? Remember, basically, what is the main purpose of experiment? To check the temperature change, right? Basically, in first experiment, we are using cold iron nitrate. In second experiment, we are checking if we add sodium thiosulfate to little bit hotter nitrate, then what will happen? In the third experiment, we are going to check, for example, if we are going to heat little bit more iron nitrate, or if we are going to add sodium thiosulfate into little bit more heated iron nitrate, what will happen then? So you are going to check the temperature of the reactant before reacting. You are going to analyze that what will happen if we add the cold reactants. What will happen if we heat up one of the reactant little bit? What will happen if we heat more one of the reactant? Similarly, what will happen if we are going to heat more and more one of the reactant before mixing? But when you mix both of the reactants and then heat it, of course, you will not be able to detect the change in the temperature, right? We are generally basically checking the rate of reaction by analyzing the temperature before the mixing of the reactants. Is it clear? So that's why you can say that describe how the result of a above experiment would
सर
change.
हम
Experiment is
सर हम
repeated. Yes, please.
हम इसे आंसर कंपैरिजन करने के लिए हमने किया है
Of course लिख सकते हैं. ठीक है. Okay.
सर
Now describe not like that. I'm just explaining के comparison. Main point is that कि reaction heat temperature increase हो जाएगा जैसे आप reaction मतलब दोनों को mix करके उसके बाद temperature increase करेंगे तो you will be unable to measure that change. या reaction तेज हो जाएगा simple ये समझ reaction बहुत ज़्यादा. Now describe how the result of the experiment would change when the experiment is repeated using 250 cm cube beaker in place of 100 cm cube beaker. Shabash kya? Instead of using 100 cm
सर
cube, excellent rate of reaction will increase, right? And lesser time will be taken to complete the reaction. I hope I'm clearing your concept regarding this question. If there is
यस
yes, so basically less amount of time will be taken to complete reaction. In other words, explanation you can as this is of 2 marks, you can say that we can easily see the result on the paper, the printed paper or the writing or the text on the printed paper because of the wider surface or lesser depth. We will be clearly and immediately seeing the text at the bottom because of wider surface and lesser depth. Clear? And lesser time will be take to complete reaction. You can use these 2 points. Oh, this is it. This is very simple, very simple, the simplest one of ATP. Two solutions have been given, solution F and solid G. First of all, test on solution F. Test 1, do a flame test. Let me tell you, let me duplicate this one so that let me tell you first that we have been given with these tables at the end of the paper. Notes for used in qualitative analysis. You will be provided with these notes, right? Inside the paper. So बार बार नीचे इन tables को देखने.
तो
Okay.
जो हमारे सैंड के पेपर्स होंगे उनमें भी गिवन होगा बिकॉज व्हेन दे
Of
विल
course given होगा yes. Okay.
सर
सर क्योंकि लास्ट जो O2 गिवन
given था.
सर ये
लाइक तुम्हारे लिए P4 फॉर GCE और IGCSE के लिए P6 दो इसी का खासियत है बेसिकली ये टेस्ट ETP में ही आते हैं हाँ उसमें आते हैं एग्जैक्टली लाइक फ्लेम दोज इंक्लूडेड
सर
फ्रॉम रेड लिटमस पेपर टू ब्लू लिटमस पेपर ये आ सकते हैं ठीक है नाउ डू
सर
फ्लेम
फिर
table will be given inshallah and also this table will also be given on first portion of solution F. Okay, now light green color will be observed. Now we are going to check the flame test किसके लिए use होता है in order to check the cation, the metallic portion of the compound of the solid ionic compound के लिए हम flame test करते हैं right. So we will be looking to check the test for metallic ion, the flame test. Light green is for barium. So one has been identified के ये तो हमारे पास हो गया barium right. So how describe how to do the flame test used in test 1. How to do it? Remember, you will have to use the platinum wire, okay? You'll have to dip it into
सर
HCl.
ये वो जो टेस्ट वाला आप कह रहे हैं टेबल ये उसमें बताया होगा उन लोगों ने
No, no, this is the flame test. This is just the procedure, and this is very simple test. और ये आपको पढ़ना है, समझना, right? This is conceptual. There is nothing to do the procedure of flame test with these tables, right? So basically, flame test आपको you can so put करते हैं. So Bunsen burner आपको identify करके देता है कि which flame test. In other words, you can write like that. You can use wire, the platinum wire, right? Putting sample into the flame using this platinum wire, right? And also the flame will help us in identifying the color change. This is simple flame test. IG311S11T or 9S or 9T को करवाया था because their syllabus was complete, and also we have ample amount of time, whereas 10S or 10T the IG2 classes. But I hope video are okay. What is the gas? Effervescence was seen, and the gas in test 2 turned the damn litmus paper to blue. Let it be checked. Look at the
सर
table. Yes, please.
टेस्ट वो
Gigi,
नहीं मुझे याद आ
can you please confirm 10T class or 10S any student?
Yes sir, कराया था।
I think you were absent that day. I have shown the videos on the projector. हमने perform नहीं किया था practically. 11 and 9 को हमने perform करा के दिया था, whereas 10T रह गया था because syllabus उनका ज़्यादा रह रहा था. ठीक है? So that's why video I will be sending video is like 0620 is the code, S23 ये सारा कुछ. S23 means it is the paper of 23. QP stands for question paper, and 62 is the code for identify the gas given off in test 2, right? Test 2 means the gas is turning damp red litmus paper into blue. Okay, so this is given, so the gas is ammonia, right? Similarly, identify solution F. How will we identify? Now look at here, clearly look at here. This is the point I want you to focus on. First of all, we have noted that the metallic cation is, what was the metallic cation? I guess it was light green barium. Barium is the cation. We are good. And what about the anion? Anion is releasing ammonia gas. So we are going to look over here which one gas will be releasing ammonia, carbon dioxide, white PPT cream. Yes, over here ammonia is being produced, right? So it means this will be nitrate. So we can say that this is basically barium nitrate. And also barium is in group 2, so we will have to write 2. In other words, barium is plus 2, NO3 is minus 1, right? So cross multiplication, much better this rule, right? So the formula will be barium nitrate. One mark is for Ba plus 2 and one mark is for NO3 minus 1, right? Now, state what would be observed if the student adds dilute sulfuric acid to another portion of solution F. This is good. We are going to add dilute sulfuric acid to another, sorry, over here. We are going to dilute, yes, for example, barium nitrate, but this is dilute nitric acid, right? So if we are going to mix sulfate ion with barium nitrate, our salt was barium nitrate. So if we are going to react it with sulfuric acid, then what will happen? A salt barium sulfate will be formed. Barium sulfate will be formed. Yes, remember we have learned the rules that all sulfates are soluble except
Barium sulfate and the other one is like
yes,
mercury sulfate, I
barium
think.
sulfate, copper sulfate, and lead sulfate. All sulfates are soluble except barium sulfate, copper sulfate, and lead sulfate. So barium sulfate is not soluble in water, right? You have studied that.
Sir, I guess it was silver, it wasn't copper.
Sorry about for that. Thank you. Silver, right? And lead. So all these three are insoluble. Rest of the sulfates are soluble. So whenever barium is going to react with sulfate, barium sulfate salt will be formed, and barium sulfate salt is insoluble. And you have also studied in acid base chapter, the insoluble salt will be settled down at the bottom of the beaker in the form of precipitates, in the form of solid white particles, right? So yes, over here white precipitates will be formed. White precipitates will be formed. You will observe white precipitates. This is all conceptual. Now solid G is iron carbonate. Again, look at here carefully. Solid G is iron carbonate. You are going to add sulfuric acid to this carbonate. A gas is given off. Now the table again. Whenever you add dilute acid to carbonate, carbon dioxide will be given off, right? Effervescence will produce. So you can say that effervescence will be produced and the gas is carbon dioxide, right? You can effervescence or bubbling or fizz up or fizzing up, right? And also it is tested. It written like any gas given off is tested. How are you going to test that? It is also written how we are going to test carbon dioxide. It is also written in the table, and that is you will have to write this one: turns lime water milky. So 1 mark is for just detecting that the gas is carbon dioxide. And how we are going to test it? We are going to pass it through lime water, and it will be turning that lime water milky. Is it clear? Similarly, your
Yes, sir.
the product of E, like for example, the carbon dioxide, aqueous sodium hydroxide is added dropwise until it is in excess. Now look at here. We are going to add sodium hydroxide into this iron carbonate. After removing the carbon dioxide, the product will be formed. For example, after removing carbon dioxide from iron sulfate by using dilute sulfuric acid, the product formed while this step, after this step, we are going to add less than 1 minute is left. Jaldi. Then you are going to add aqueous sodium hydroxide in excess over here. This is aqueous hydroxide. You will have to find these insoluble in excess. Right. So you will find the answer over here. So the main purpose of these classes were to understand you that how you are going to read the tables and solve the ATP paper. Is it clear?
Yes,
Yes, sir.
sir.
Especially, please respond me all the TCS students, please. The 10 students, 10T, 10
Yes, sir.
Yes, sir.
respond me.
sir.
Yes, sir.
They are having paper. And also, what about 11S, 11T, and APS? Clear? The major idea.